Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 8, ExC4 Discuss. Our today's lecture number is 40 and SW number 35. So my dear students, let's start our class. Today we will discuss ExC4 from chapter 8. At first see this figure. Now this is the stem. Here given concave mirror. That one is a concave mirror. Okay, here this one is a concave mirror, and here F is the focal length and C is the center of the curvature, and this is the object. Okay, so from the and this is pole P. So from the distance from the pole to the object is 30 centimeter. That means this is the length of the object is 30 centimeter, and here focus is 6 centimeter is given in the stem. So my dear students, see now question A, what is regular reflection of light? Question B, what do you mean by principal focus? Question number C, find the distance of the image. And question number D, find the magnification power and curvature of the instrument. Okay, so my dear students, see the answer. At first, what is regular reflection of light? And the definition of regular reflection is if a parallel beam of light falls on a smooth surface and after reflection remains parallel or is converted into a convergent or a divergent beam, then such type of reflection is called regular reflection. Now question number B, what do you mean by principal focus? My dear students, the answer will be a beam of rays adjacent and parallel to the principal axis being incident on a spherical mirror converges at a point on the principal axis. Okay, this one is the spherical mirror for convergence at a point on the principal axis. In case of concave mirror, this is for concave mirror, or appears to be diverging from a point on the principal axis, and in case of convex mirror. Okay, so for concave mirror, the convergent at a point on the principal axis, and for the convex mirror it's appeared to be diverging from a point on the principal axis, and after reflection then this point is called principal focus of the mirror. My dear students, I am repeating this question answer again. What do you mean by principal focus? A beam of rays adjacent and parallel to the principal axis being incident on a spherical mirror converged at a point on the principal axis in case of concave mirror, or appears to be diverging from a point on the principal axis in case of convex mirror. After reflection, then this point is called the principal focus of the mirror. My dear students, for principal to write down the definition of principal focus, you have to describe for the concave mirror and also convex mirror. Okay, see this figure, the principal focus of this mirror. See, that one is a first we will draw a figure of a concave mirror. Okay, suppose this one is a concave mirror, and this is the principal axis, and this is the principal axis, and this is the center of the curvature. Okay, center of the curvature, and that one is the focal length. So my dear students, the parallel light ray coming, it is incident on the concave mirror. Okay, it is incident on the concave mirror, and after reflection it will go through the principal focus, go through the focal point. Okay, so after reflection it will go through the focal point. Okay, after reflection it will go through the focal point, that means this point F. Okay, this is the, in case of concave mirror, they are converging, all light rays are converging at this point, focal point F. So for concave mirror, F is the principal focus. This is the principal focus. Now convex mirror, I'll show another figure for convex mirror. This one is a convex mirror, and this one is the principal axis. This one is pole P. This one is the focal. This is the focal point. Okay. So parallel light rays coming. That one is a convex mirror. So this side is convex side. Okay. Parallel light ray coming, incident on the this mirror, and after reflection it will go this, and if we extend this line it will this focal point. Okay. So for the convex mirror, it is the all light rays diverging from a point on the principal focus, and that one is the principal focus of the convex mirror. Okay, my dear students, now I will show the answer question number C. Question number C. Find the distance of the image. My dear students, we have to find out the distance of the image. So in the STEM at first given the distance of the object u is 30 centimeter. The distance of the object is given u is 30 centimeter, and the focal length is f equals to 6 centimeter. So we have to find out the distance of the image v equals to what. And my dear students, we know this formula 1 by v plus 1 by u equals to 1 by f. And now we will use this formula. We have to find out the image. So we have to find out the v, 1 by value of v. So value of v equals to 1 by v equals to 1 by f minus 1 by u, and now we will put the value 1 by f means 6 minus u means 30. Okay. So we have to take LCM from 6 and 30. It will be 30. 6 divided by 30, that means 5, and minus 30 divided by 30, that means 1. So 5 minus 1, that means 4 divided by 30. So v equals to 30 divided by 4, and doing this calculation it will get 7.5 centimeter. Okay, this is the distance of the image. And now we will find out question number D, the magnification power and curvature of the instrument. My dear students, again we will show the from C we get f equals to from question number C, from f equals to 6 centimeter. For focal length f equals to 6 centimeter, and if we convert this centimeter into meter, then it will be 0.06 meter. Okay, now power, we have to find out the power. P equals to 1 by f. This is the formula. You have to memorize this formula. P equals to 1 divided by f. That means f means 0.06 meter. That means it will be plus 16.67 d. This is the power of this image. Okay, and now magnification m equals to v divided by u, absolute value of b divided by u. So it will be v means 7.5 and u means 30. Okay, so it will be 0.25 is the magnification of this image. And now we will find out the curvature of this, that and C curvature C equals to 2f. My dear students, this is the another formula. You have to memorize also this formula. Okay, curvature of the instrument C equals to 2f. So 2 into f means 0.06. Okay, it will be 0.12 centimeter. So this is the curvature of the instrument. Okay, my dear students, I hope all of you have understood our today's topic, and your today's SW number is 35, and C and D is your SW. My dear students, I hope all of you have understood today's topic, that means this CQ. Practice properly at home, and see you again in the next class. Allah Hafiz.